Welcome to the Hoja on Architecture podcast. Vernacular Architecture, Chapter 7, Technique as an Output. Building materials and construction techniques are inseparable. The word technique comes from the Greek word for art, the techne, which means the branch of knowledge or skill needed to make an object. As told before, certain materials make specific building techniques available. Stone is not available to stretch where the hides are unavailable to pile up, and some materials are available for different methods. Therefore, remarkably diverse results can be achieved from the same material. Architecture relies on a straightforward relationship between the load and the load-bearing element. All building materials have weight, therefore they are affected by gravity. Static elements like walls and roof are called dead loads, where climatic factors like snow and wind, furniture, and even occupants are the live loads. Delivering the gravitational loads to Earth is the duty of the structural system. Stresses on these building components can be broadly classified as tension, compression, and shear. Usually, vernacular builders employ muscle power through hammers, chisels, levers, or saws. Animal power is only used for transporting heavy materials or carrying the dismantled building in the transhumance economy. Vernacular construction uses human proportions, such as the imperial system, including inches, feet, yards, and many local variants. This study labels the material technique group of its outputs as know-how. Within the context of vernacular architecture, it embraces what is known and what is inherited, includes the collective wisdom and experience of the society, and embodies the inherited knowledge of climate, topography, seasonal cycles, natural hazards, and sustainability. As not only constructors but also occupants of the structures in question, the people of vernacular societies have to learn how to obtain materials and bring them together with necessary tools, and how to build according to the norms and values of their communities. Inevitably, this construction process creates a unique specialized language and its terminology. Those make the know-how of each distinct society even more esoteric. Learning to build is a threshold for becoming a fully participating community member in many places, and the skills are transmitted from one generation to the next as an educational process and part of their tradition. Since each individual is not equally skilled, some kinds of specialization become available, such as stonemason, carpenter, and blacksmith. This study also finds the existence of those masters in construction as a challenge to the definition of vernacular architecture. Of course, these vernacular techniques did not emerge overnight. Each results from centuries or even millennia of trials and errors and is subject to constant change. We are now in a position, as the vernacular builders often are not, to evaluate their techniques with modern architectural measurements and compare them with cultures displaying similar climate, material, or technique. Yet vernacular architecture reveals a very high level of performance even when judged in the light of modern technology. In sum, before discussing further details of material species, it will be helpful to define the technique this study coined: know-how of what to do with the building material, or in other words, the knowledge of the method of construction. As a significant part of earthen materials, earth itself is used with quite different techniques worldwide. The first technique is a very interesting, offering not to build up but to carve. This technique includes the horizontally dug caves and vertically sunken pits. Both options result in unconstructed ready walls. They are sometimes supplied with partial construction of log, earth, or stone, as in the Zemlyanka sample from Russia. Another fascinating sample is from Cappadocia, Turkey, where interiors were carved from the eroded volcanic tuff. The second technique is directly building with wet mud, known as cob in England, and swish in Western Africa. The third technique is also known as sod, which offers to cut bricks out of the turf. The fourth technique is rammed earth, pied de terre in French, or tapia in Spanish. This technique is popular in France, Morocco, India, and China. The method is forming a wall-sized wooden mold, filling it with mud, and tamping with a pole until a compact layer is gained with the ejection of air bubbles. This technique is applied layer by layer to form a wall. The fifth technique is wattle and daub, or Baghdadi in the Middle East. It is a mixed technique of earthen material and vegetative material. The branches are woven to form a basket, and this structure is plastered with mud. This is one of the most common techniques in the tropics and mid-latitudes. There is also an unusual method, called super adobe, of filling bags with earth or sand and piling them up. Architect Nader Khalili pushed this latest technique. Adobe is the most sophisticated method of earth, which must be evaluated separately. The term comes from the Arabic al-tob and means to form bricks out of mud, shaped either by hand or by wooden molds, and finalized by drying under solar radiation or firing in the kilns. Adobe displays high thermal capacity, which makes it an ideal tool in places with greater daily heat fluctuation, like hot arid climates of the Middle East and North Africa. It absorbs the heat during the day and transmits it into the interiors when needed at night. The harsher this climate gets, the thicker the adobe walls are built to adapt. One of the most interesting samples of sun-dried adobe is the Muscum mud huts from Cameroon in a pointed tall dome form. Yet another one is from North America and known as Pueblo. American natives used sun-dried adobe even in the pre-Columbian era. The most famous of them, which is also a tourism target, is Taos Pueblo from New Mexico, United States. The term adobe is frequently used only for the sun-dried version, where the baked one is called fired brick. Fired bricks are more expensive than sun-dried versions since firing them consumes enormous fuel, mainly wood. In many areas, it is only used by the wealthy. Fired bricks are brought together with suitable mortars. It is a more durable and fire-resistant material than stone. However, unlike the sun-dried adobe, it cannot be reused. This non-renewable feature, along with rising fuel costs and increased popularity of modern materials like concrete, calls into question the use of fired brick. Especially in the Middle East, its application is relatively rare, mainly because of the absence of firewood to use as fuel. Adobe is on its way to becoming a standalone academic field of study since many scholars are interested in the subject, with various ongoing research and published studies. Another earthen material, stone, is used a few miles from its origin since it is heavy and expensive to transport. Quarrying, carving, shaping, and assembling the stone is also challenging and time-consuming. Therefore, only sedentary people tend to use it. Because of its highly durable identity, stone is more frequently used in communal buildings like temples or palaces, engineering projects like roads and bridges, and defensive fortifications. Such major work needs specialized artisans and falls outside the definition of vernacular architecture. Nevertheless, though lesser than the earth, stone is also used in vernacular projects. There are dry and wet techniques. The dry one involves piling the rocks and sometimes ending with a corbelled dome. The wet one, on the other hand, requires mortar. A popular example of a dry stone system is the Trollo from Italy. As told earlier, this study accepts snow in the earthen materials group. As expected, it is used in the northernmost geographies since Antarctica is uninhabited. The most famous igloos of the Inuit people are temporary dwellings during hunting seasons. They are of snow cut into prismatic blocks and laid in a spiral orbit, trimmed to slope inwards to form the hemispheric dome. This structure is later plastered with ice to increase its thermal quality, and the interiors are furnished with hunted animal fur. Many igloos are partially underground or sunken like pit houses. There are other techniques like piling up the snow and carving. Another earthen material, the metal, was mentioned earlier. This material either reaches vernacular people via trade, especially after the railroads, or is used by the urban vernacular surroundings. As is known, the other leading material group in this study is organic materials, which are mainly vegetative products. Though the problem of rapid deforestation exists, nearly one-third of the world's land is still covered with forests. Thanks to this abundance, building in timber is the standard construction model in humid areas of mid-latitudes. There are two basic methods of timber construction. First is the use of logs as themselves with the minimum process. Log construction, known as Blockbau in Germany, is the principal method of using the log's dead weight, but not their tensile properties, by piling them up. Of course, it consumes a lot of wood for framing. Corner joints of the piled walls are the main problem, and various interlocking details are provided worldwide like saddle or V-notch. The Russian Izba and the German Black Forest house, the Schwarzwald house, are famous examples. The other method is timber framing, or in other words, the half-timber technique. Here, only the structural elements are of timber, and the tensile strength of the wood is used on the post and beam principle. Doubling the length of the beam halves the load it can bear, but doubling its width and depth will quadruple its strength. Frames provide support, but not the screening. The curtain walls between the posts are filled with materials and techniques worldwide. When the wood is plentiful, the infill is made of planks. Stone, mud, and woven bamboo are the other options. There are various framing techniques like the box frame, balloon frame, cruck frame, or English cruck frame. Half timbering is preferred because of timber exhaustion or rising costs. The widely used wattle and daub technique was mentioned in the earthen materials group. As a reminder, it is of woven branches plastered with mud. Another vegetative group of materials is of grasses, leaves, and reeds. The grass is unsuitable as a structural element because of the attenuated length-width ratio. Still, thanks to its flexibility and elasticity features, they are tied together and used. Reeds are bundled together for structural use as a specific type of grass. The famous Marsh Arab guest house, the Mudhif from Iraq, is a fascinating sample of vernacular architecture of this type. The other grasses and agricultural leftovers are a binding ingredient in the adobe. And some grasses, generally dried, are used in thatch roofs as a covering. Bamboo is a unique type of vegetative material. There are numerous bamboo types, some cultivated just for construction purposes. Divided by nodes, bamboo allows extremely high compression with relatively light construction. Bamboos are also used in the post and beam technique because of their tensile properties. More, because of its favorable material properties and rapid growth in places with higher population density, bamboo is said to play an essential part in the future provision of ecologically sustainable and culturally appropriate housing. Generally, the raised stilt structures are made of bamboo, and the piles allow living directly on the fish schools, space below for dehumidifier winds, or protection from insects, wild animals, or foreigners in different settings. As mentioned earlier, animal products are a small group of construction materials in vernacular architecture. There is historical evidence of using the rib bones of giant animals for structural purposes. On the other hand, felt, hide, and fabric woven of animal hair are widely used, spanning elements, especially in tents today. Moreover, we already know that dung, seashells, tallow, and cassin are used as binding ingredients in mud for structural purposes or plastering. Before ending the techniques section, mentioning the finishing and roofing methods is also useful. One of the most common vernacular finishes is mud plaster, with straw or similar additives, sometimes molded or colored for decorative reasons. Another standard finishing is lime plaster, applicable on earth, stone, or timber. Different additives, mainly animal products like fat, are welcome to increase water resistance. And the reflective color of lime is widely used to decrease solar radiation. Roof, on the other hand, is always the main problem in vernacular architecture. A wide variety of local materials, in both earthen and vegetative forms, function as roof coverings from grasses, leaves, straw, bamboo, bark, branches, timber, and logs to shingles, shakes, tiles of turf, sod, mud, and even stone. Since the fired brick is resistant to water penetration, specially formed roof tiles are popular in widely distributed forms like Chinese, Spanish, Greek, and Roman versions. A special form of vegetative roofs, the thatch, is another wide form. Mainly in the tropical hot humid areas, the thatch is the primary strategy since the roof must be solid and opaque against the heavy rain and high solar radiation. However, the vertical surfaces are decreased for dehumidification purposes. Therefore, the structures become giant umbrellas. Thatch is the generic name for roof coverings made of dead plants other than wood. Grass and palm leaves are primarily used in Latin America, Sub-Saharan Africa, and Southeast Asia, where straw and reed are common in Europe, China, and India. Although the major problem with thatch is not the water leakage but high wind damage, it has genuine advantages like price, use of locally available material, and reuse as fuel. Since then, thatch is the world's most commonly used roof covering. Various samples can be found in Florida Seminole, the United States, Mexico, the Caribbean, and Melanesia. Teachings of vernacular architecture envelop techniques as well as the materials. Since some local techniques were left and the modern prefabricated methods replaced them, especially after the Industrial Revolution, humankind has brand new problems like global warming, deforestation, climate change, unrenewable energy consumption, etc. Hopefully, many vernacular builders still rely on local methods, which is coupled with a disinterest in using advanced technologies and resources. As we know that the ecological irreversible threshold is near, we have a short time to study existing natural solutions of vernacular societies and adapt their strategies to formal architectural design. This is the end of the vernacular architecture. Chapter 7. Technique as an output. Thanks for listening. See you in the next episode.